Hello everyone, today I would like to show you how to solve the Laplace transform of the unit step function. Okay, first of all, let me show you the theorems. So Laplace transform of delta t minus a equal to 0 to infinity exponent negative st delta t minus a dt. So this will result in exponent negative as. So whatever Laplace transform of delta t minus a, you will obtain exponent negative as. So this is the theorems. Okay, now let's look at the example. Let's say if you have the Laplace transform of the delta t minus 3 minus delta t minus 6. Okay, what will be the answer? Okay, as you know, Laplace transform of delta t minus a, you will obtain exponent negative as. So if you have the Laplace transform of delta t minus 3, so for sure you obtain exponent negative 3s, as the a is equal to 3. So you have exponent negative 3s, and then minus with delta t minus 6. The a is 6, so you have exponent negative 6s. Okay, we directly solve the question. Okay, second, if I have a Laplace transform of the delta t minus 2. Okay, 8 is a constant, so you can take out the constant, so this become easy. So now delta t minus 2, you will obtain exponent negative 2s. Okay, this is easy also. Okay, let's look at the next one. What if you have the Laplace transform of delta t plus 5? Okay, if t plus 5 means that the t is equal to negative 5. This negative 5, the value of a is, okay, the value of a is not within the interval 0 to infinity. Okay. As I mentioned to you before, the shifting property is the PQFT delta t minus a dt equal to fa, and then the a is in between p and q. That's why when you check for the delta t minus a, so this a equal to negative 5 is not within the p and q. Okay, it's not within the 0 to infinity, it's at the negative infinity, negative 5. So it's not within the 0 to infinity. So therefore the Laplace transform delta t plus 5 is equal to 0. Okay, next. If you have the Laplace transform of the exponent t delta 2t minus 3. Again, we are dealing with the 2t minus delta 2t minus 3. So we use the substitute method. So we assume that the u is equal to 2t. So t is equal to u over 2. So we differentiate the t, so you have dt over du. You will obtain half. So in order to find the limits, we assume that when t equal to 0, u will equal to 0. When t equal to infinity, u will be also to infinity. This is for the limits. Okay, now you have we continue from here. So Laplace transform, okay, we change every t to u over 2 and change the u to 2t. Okay, now you have exponent u over 2 delta 2t is equal, you substitute with u minus 3. Okay, just now we talked about the formula for the Laplace transform of unit step function. We use this formula. If you have the Laplace transform of the delta t plus a, we can use this formula. Okay, so we use this formula: 0 to infinity exponent negative st, and then we continue with exponent ut u over 2 du minus 3 dt. Okay, and then we simplify. So this one, okay, again here you have t, here you have t, you have to substitute the t with in term of u. So negative s u over 2 exponent u over 2 and del d u minus 3 du over 2, then equal to, so this half we can take it out, so it's a half exponent. Okay, here you have we take out the u, so you have half minus with s over 2 u, then d u minus 3. So this du minus 3 actually it means that the impulse response occur at u equal to 3. Okay, so from here we know that, okay, this is in terms of du. Okay, integrate in terms of u du, so it's a fu. So this is du, so for sure this is fu. So this is fu equal to exponent half minus s over 2 u. Okay, so it is equal to fa. You still remember the formula? The equal to fa equal to half minus s over 2, and then the u that we obtain from here is 3. Then we substitute with 3. So use the result. Okay, just now we have the formula, still remember, pq ft delta t minus a dt equal to fa, right? Okay, so by using this one, and then the Laplace transform of the exponent t delta 2t minus 3. Okay, delta 2 minus 3, this is the question. So equal to half, because you have the half here, so it's a half, and then this whole thing we obtain the exponent, so is equal to exponent 3 half minus s over 2. Okay, now I show you another example, the quite similar type of the question. So let's say Laplace transform of t square delta t minus 3. Okay, so usually we express the delta t minus something. So for easiness, we just change the position into Laplace transform of t square delta minus t plus 3. Okay, then we use the substitution method, and then we assume that the u is equal to negative t. Okay, u is negative t, and then we know that from here t is equal to negative u, and then we differentiate the t equal to dt over du. You will obtain negative 1. And then in order to use the limit, so when t equal to 0, you obtain When t equals 0, u also 0. When t equal to infinity, u is equal to negative infinity. Okay, then back to here. Okay, so now you change the t into negative u and change the u to negative t. So you have the Laplace transform. Okay, t square is you change to negative u square. Delta negative t you change to positive t lah. Negative t you change to u, so it's u plus 3 dt. Sorry, it's just u plus 3, no dt. Okay, so next step is we use the formula of the Laplace transform of unit step function. So we use the formula from 0 to infinity, exponent negative st, and then we follow this one, u square delta u plus 3 dt. Okay, since the t is a negative t, so we change the direction. So integration of 0 to infinity also same as negative integration from negative infinity to 0. So we now change the direction. So negative infinity to 0, and then negative st again we change in terms of u, then u square delta u plus 3 dt change to negative du. Okay, then we simplify this negative, and then this negative become positive, so remain positive. Exponent su u square delta u plus 3 du. Okay, so from here we know that the u equal to negative 3, or we can set the a also, or we can set a equal to negative 3. Okay, since this is over du, so fu, so this is fu du. Okay, fu equal to exponent su u square, and then it would be equal to fa equal to negative 3. So means that the u will be substituted with the value of negative 3. So you will have a 9 exponent negative 3s. So by using the result of the formula pq ft delta t minus a dt equal to fa, we use this. So the answer will be, so Laplace transform of the t square delta t minus 3 should be equal to integration from negative infinity to 0. This one is exponent su u square delta u plus 3 du should be equal to 9 exponent negative 3s. Okay, so hopefully give you a few examples with a different style, so you can understand. Okay, thank you for watching.